Hi everyone, myself Amrutha, Assistant Professor, Department of Computer Science, St. Albert's College, Botany. Today we are going to have a session in Advanced Data Structure. The topic is linked list. So first of all, moving to the topic linked list, let us understand what is an array is. An array is a static data structure, whereas linked list is a dynamic data structure. What is the difference between a static data structure and a dynamic data structure? In the case of static data structure, we want to define the size of the array before the runtime. But in the case of dynamic data structure, we can define the size of the list before the runtime. Also, we can increase the size. So these are the disadvantages or the limitations of the array. First of all, in the case of the array, the size of the array must be known in advance. That is, we cannot increase the size after the runtime. Before we want to know the size of the array before the program. So in the next one, that is the increasing of the size of the array takes a lot of time. That is, it is impossible to expand the size of the array, that is at the runtime. We cannot when the time size of the array is fixed at the program in declaration part, we cannot increase the size during the runtime. It is fixed. And in the next case, all the elements are stored in the array in a continuous memory locations. So that in order to insert an element at this particular specific location, we want to shift all the elements towards the right. In the case of the deletion also, if you want to delete a particular element from a location, we want to shift all the elements towards the left. Then only we can insert at a particular location. So these all limitations can be overcome in the linked list. The linked list, it is a dynamic data structure. We can increase the size after its declaration also. So linked list is a data structure which can overcome all the limitations of the array. So it allocates the memory dynamically, which I already told. The sizing is no longer a problem because we can increase the size after the declaration also. If you want to increase, if I want to increase the size, so it can increase the size during the runtime also. So in the case of the array, the data are stored in a continuous manner, whereas in the linked list, the data are stored in non-continuous manner, but the nodes are linked together with a link pointers. So in the linked list, it is a linear data structure, whereas array is also a linear data structure. The difference between a linear data structure and a non-linear data structure is that in a linear data structure, the elements are stored in a sequence manner. The example is linked list and the array. Whereas in non-linear data structures, the elements are not in a continuous manner displaced. It is placed in a hierarchical manner. That means there will be no sequence. For example, tree and a graph. So in the linked list, the elements are not stored in a continuous manner, whereas in array, the elements are stored in a continuous manner. So in the linked list, which I already told this, the elements are not stored in a continuous manner. Then how it is possible, the linking process? So all the nodes are being linked together. So in a linked list, each node will be containing two parts. That first one is data and the second one is the address part. The data part means the actual value of the node. If I want to store 3, then 3 will be the value of that in the data part. In the next one, that is the address part. In the address part, that is a linking together. That means after the node which comes after this node, which will be the address of that node will be in the address part. So in each node which containing two values, that is the address and the data. And the next one, that is in the case of a linked list, there will be a head pointer which will be pointing to the first node, and all the last node which will be pointing to the null value. So these are the main features of the linked list. In the case of a linked list, each node will be containing two values. The first one is data, the second one is address. The data means the actual value in that actual value, the information which we have been storing, and in the address part which contains the address of the next node. And there will be a head pointer which points to the first node. Every first node which will be pointing to head, and every last node which will be pointing to the null value. So this is an example of a simpler linked list. That is, you can see here multiple nodes can be seen. Each node will be having a data and the value. The data and the address. This is the data part and this is the address to the next node. So here you can see multiple nodes are visible, and the first node will be pointing to head. The head will be pointing to the first node, and the every last node which will be pointing to the null value. So next we are going to check what is the need of the linked list, which I already told you what is the need or what are the advantages of the linked list, why we are using a linked list. There are a lot of limitations in an array. In the case of an array, the size of the array is fixed during the declaration part itself. We cannot increase the size according to our need during the runtime. So if I declare the size of the array as a large size and I am not using that space, then there will be wastage of memory spaces also will be there. And the case of the inserting an element in an array, it will be an expensive one, because which I already told in the beginning that if I want to insert a particular element into a specific location, then we want to shift all the elements to the next part, next shift. Then only we can insert to a particular space. So whereas in the case of deletion also, if I want to delete a particular element from a specific location, I want to shift all the elements towards the left. Then that expensive will be very high. This can be overcome. These limitations of the array which can be overcome in the linked list. So the linked list, which is a dynamic memory allocation, which means we can increase the size during the runtime. It is not fixed one. We can increase the size during the runtime also. So and also in the case of the insertion and the deletion operation, which will be expensive, will be very less comparing to the array, because we don't want to shift all the elements towards right and left. If you want to delete or insert a particular element to a fixed location, it is easier than the array. Next, what are the different operations which we can be performed in a linked list? So these are the operations which we can perform in the linked list. The first one is insertion, the second one is deletion, and the third one is displaying the operation list, and the last one is we can searching the operation. The first one, insertion, we can insert a particular element at a particular positions, and deletion also we can delete a particular element from that particular locations. Displaying means we can display the complete linked list, and searching means we can search a particular element is there present or not, can be done, operations can be performed in the linked list. So next is the different types of linked lists. There are different types of linked lists, such as simple linked list, which is also known as simply linked list, and the second one is double linked list, and the third one is circular linked list. Now let's see what are these differences between these three. The first one is singly linked list, or which we can it is a simple linked list. So in the singly linked list, it can be defined as the collection of an ordered set of elements, which I already told. It is a sequence. The elements are not stored in a continuous manner, but there will be a sequence of manner is there. So it's a collection of an ordered set of elements, and in each node will be containing of two parts. The first one is address, and then second one is the data or the value of the information stored. So this is an example of a simply linked list. You can see here there are three nodes are present here. The first node, which will be pointing to head, and each node will be containing a data and the address to the next node, and the last node, which will be pointing to a null value. So this is a circular linked list. What is the difference between a simply linked list and a circular linked list is that each node will be containing two values itself, that is the data and the address of the next node. Whereas the difference is that in the case of simply linked list, the last node will be pointing to null value. Whereas in the case of circular linked list, the last node will be pointing to the first node, and it forms a circle. That is the main difference between a simply linked list and a circular linked list. That is, in a simply linked list, the last node will be pointing to the null value, whereas in the circular linked list, the last node will be pointing to the first node, whereas all other parts are same. Each node will be having a data path and the address to the next pointer, and the first node will be pointing to head, and that is the main difference between the single and the circular one. Then whereas one more linked list, that is the doubly linked list. In the case of doubly linked list, it consisting of three fields, that is the data and the two address will be there. The data, which is the actual information stored, and the address means there will be two address will be stored. First one, that is the address to the next pointer and address to the next node, and the previous address will be also stored in the doubly linked list. So you can see here, this is an example. In the case of, here you can see multiple nodes are present here. The first node which will be points to head, and the last node which will be point to null value also. Here one more thing we want to think, that is the head pointer, which each node will be containing 3 values. The first is the data part, and the 2 address, that means next address and the previous address will be there. The first node which will be not pointing to any nodes, so that is the previous value which having a null value will be setting as. So and all each having a next address and each having a previous address will be there. So this is an example of the simply doubly linked list. So in this lecture we have been understand the simple linked list and the what's the difference between the simply linked list and the circular linked list and the doubly linked list. So actually what do you mean by a linked list is a whereas the array is a static data structure, whereas linked list is a dynamic data structure. In a dynamic data structure we can increase the size during the runtime, whereas it is not possible in the static data structure. So I think by this lecture you understand what you mean by say linked list and